So, in this part, we'll speak about hedges or hedgerows as an important infrastructure related to the biodiversity in the farm. However, we have to know now, you are familiar that every agriculture practices has not only one impact or has not impacts only in one direction. It has many beneficiaries, many positive impacts in the agroecosystem. I continue to speak about soil fertility management, to speak about the practices that influence to the soil fertility. I will speak here about hedges and hedgerows. Let's speak about hedges and other refuging areas. What is an hedge or hedgerow? An hedgerow is a line of closely spaced shrubs and sometimes trees planted and trained to form a barrier or to mark the boundary of an area, such as between neighboring properties, between agricultural land and roads, and so on. As mentioned previously, hedges or other refuging areas has multiply functions. For example, they increase biodiversity, which from its side has different advantages like serve as a refugee, shelter and food for natural enemies, shelter and feed for wildlife, including birds, increase of biodiversity in the soil, and so on. Hedges are planted many times to serve as a repellent for particular pests or trap plant for others. It breaks the winds, protecting crops from wind and reduction of wind soil erosion. Slow runoffs, contributing to reduction of soil losses, doing water conservation, and other services related to water in the soil. Contribute to carbon sequestration, keep soil protecting from slide in the slopes, so deep roots of trees can protect the soil from slide. Break the wind with salt near sea coast, has aesthetical function, and sometimes can produce fruits for consumption. Here you have a list of some of the tree, shrub, and herbaceous species that are found in the hedges. So they can be herbaceous or a combination of herbaceous shrubs and trees. So in this case, the hedge can be more fit, more dense, and from the other side can offer biodiversity, higher biodiversity, and much more benefits compared to the main crop. So, for example, we have hawthorn here, Fagus species, Prunus, Quercus, Salix, Tilia, Taxus, Thuya, Tamarix, Myriastica fragrans, and so on. You will have the list in the repository in the platform, so please download there and have a look on the different species. You can compare with species that are used in your area, and in this case think about benefits that offer each of these species. In this photo you have the illustration of the hedges. The photo is taken from above, and so you see different plots that are separated from each other by hedges that in this case can serve as border if the plots are from different farmers, but in the same time, it plays important role as an biodiversity infrastructure with all the benefits that I mentioned in some slides previously. Samely, here we have the example of cereals, that is a planted crop, and the hedges that separate different plots. In fact, hedges are not the only infrastructure which contributes to biodiversity and offer the other benefits that um, are mentioned for them. There are other refuging areas with the same ecological functions like walls, bird nests, stones, forests, and watersheds. Stone walls. There are another infrastructure which is helping the biodiversity, can serve as a refuge for the beneficiary insects, can protect the soil from erosion, from floods. So there are multiply benefits from dry stone walls. These walls we find usually, especially in the Mediterranean countries like Italy, Albania, Greece. So there are these areas that I might personally have seen as ecological infrastructure. Sometimes people, simple farmers, probably don't know the benefits of them because these dry stone walls coming from long old times. But however, they have seen the benefits of the use of stone walls. Mulching. What is mulching? Mulching, in fact, is another agricultural practice, important one, especially used in organic farms, covering the soil with straw, cut leaves, leaf litter, compost, paper, or plastic sheeting, which are spread on the ground around plants to prevent excessive evaporation or erosion, and meantime enriches the soil, inhibit weed control and erosion. So the main advantages are the mulching increase the microbial activity, encourage worms in favor of soil, suppress growth of weeds. As mentioned in the definition of the mulching, another advantage is a reduction of the evaporation of the water, and in this case it helps to maintain the humidity. It prevents soil erosion, add nutrients to the soil because it is mainly plant residues which can be degraded in the soil. The mulching protects soil from harsh temperatures, especially in hot seasons. Keep structure of the soil. When the mulching is used, farmers see that the soil is less compacted. It protects soil against wind and water erosion and enhances the microorganism activity. So there is a higher microorganism activity. Crops such as tomatoes, melons, and cucumbers are especially benefited by mulch. All these mulches can be dug into the soil when the season is over. Here is the example of mulching or a mulch. In fact, the material is straw, so we have a straw mulch. You see, in this part there is straw mulch, and in this part is not used yet the straw. to do mulching. Yet another example, the mulch is here. This mulch can be associated with no-tillage practices, or the mulch can be added even later from outside the plot or outside the field. Another material that is used for mulching, here we have plastic, which I'm not a lot in favor of the plastic. Another example of mulching, here we have compost mulching of the trees. So we put compost around the trees near the trunk. When we speak about nutrients, immediately we link it with soil fertility, with nutrient content in the soil, with nutrient management practices, agricultural practices that save, conserve, and improve their content in the soil. However, we have to mention here that the source of the nutrients is not only the soil, it can be the air too. However, the essential nutrients of the plants, they are grouped in two main groups. The first one is the group of nutrients which is needed in large amounts, and the other group is the nutrients which are needed in small amounts. Here we have the name of the element, we have the common available form and the source. For example, let's speak about carbon. Carbon is being taken by plants in the form of CO2, and it is found in atmosphere. Oxygen comes from atmosphere and soil pores. The same for water. Hydrogen is in the form of water and is found in soil, in the water which is present in the soil or in the soil pores. Nitrogen in the form of nitrates and ammoniac or ammonium, which is found in the soil. Phosphorus is in the soil, potassium the same, calcium, magnesium, and sulfur. Then, in smaller quantities, we have iron, manganese, copper, zinc, bore, molybdenum, chlorine, cobalt, and nickel. You can consult this table and try to memorize or understand better. Downloading it in the form of a file, of a Word file, which is in a repository files. For better management and conservation of nutrients, there are advisable different practices, agricultural practices in the farm. For example, it is important to build up and maintain high soil organic matter levels. It is advisable to test manures and to analyze their nutrient content before applying fertilizers or other amendments. Incorporate manures into the soil quickly if possible to reduce nitrogen volatilization and potential loss of nutrients in runoffs. Test soil regularly to determine the nutrient status and whether or not manures, fertilizer, or lime is needed. Balance nutrient inflows and removals to maintain optimal levels and allow a little drawdown if nutrient levels get too high. Enhance soil structure and reduce field runoff by minimizing soil compaction damage. Use forage legumes or legume cover crops to provide nitrogen to following crops and develop good soil tilth. Use cover crops to tie up nutrients in the off-season, enhance soil structure, reduce runoff and erosion, and provide microbes with fresh organic matter. Maintain soil pH in the optimal range for the most sensitive crops in your rotation. When phosphorus and potassium are very deficient, broadcast some of the fertilizers to increase the general soil fertility level and then apply some as well. To get the most efficient use of a fertilizer when phosphorus and potassium levels are in the medium range, consider band application and planting, especially in cold climates. This table is for consultation only, just to have an idea of some main important fertilizers and the macronutrients and micronutrients they supply in the soil. There are amendments or fertilizer that mainly are used in conventional agriculture, and some one of them can be used in organic agriculture. You see the macronutrients considered here are nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, and chlorine. You see here different concentration, content of nutrients. These are different fertilizers for phosphorum or the combination of nitrogen and phosphorum materials. Potassium materials, which are used to supply potassium in the soil. And here the other materials, some of them can be used in organic agriculture, like gypsum, limestone, or wood ashes, or sulfur can be used. However, remember that in organic agriculture, we aim to supply nutrients mainly based on rotations, based on green manure, animal manure, use of compost. I mean, mainly based on the recycling of the nutrients within the farm, with the objective to minimize the use of external inputs or external supply of nutrients. This table shows now different products used by organic growers to supply nutrients. We have alfalfa pellets, blood meal, bone meal, cocoa shells, colloidal phosphate, compost, cottonseed meal, fish scraps dried and ground, granite dust, green sand, hoof and horn meal, linseed meal, rock phosphate, seaweed ground, soybean meal, and tincage. I will not mention all the numbers here. The nutrients considered and analyzed here are nitrogen, phosphorus, and potassium, that are the most important macro elements. Different materials have different content of them. Some of them has more or can be a main source of nitrogen, and some of them can be source mainly for phosphorus and some others for potassium. As we see, most of the materials have very few content of the potassium. So the richest one is green sand, and then the other one is granite dust. regarding phosphorus, the most richest one are bone meal. In the first place is rock phosphates, which are minerals, are natural rocks which are grounded and are rich in phosphates. And speaking about nitrogen, in fact, there are very few natural materials that can be used in organic agriculture and have high quantity of nitrogen. For example, the richest one is the blood meal, and then comes hoof and horn meal, seaweed ground, and so then the other materials. Compost here is 10%, but from my experience, most of the compost has about 1.5 to till 3 or maximum 5% of nitrogen. Water. Water is an important substance for plant nutrition, for plant growth. We say the water is equal life. So it is important to practice or to use agriculture practices for water conservation, especially in these times that we are facing problems with climate change, which in different regions, in different seasons, create problems of drought. So for water conservation, we can advise to do a reduction of evaporation through mulching, cover cropping, and intercropping. Reduction of runoffs through cover cropping, mulching, counterplowing, terracing. Use of manure, animal manure, or green manure, and organic materials with high water capacity. For example, soil humus has high water capacity, and in this case it increases the soil water retention, soil water capacity, so we in this case can reduce water losses. It is a way of water conservation. A reduction or elimination of water pollution. All methods suggested in organic agriculture are based on agroecology principles. Creation of hedges so they slow down runoffs and keep rainfall water on their biomass. Water harvesting practices can be one example or one practice that can advise for a better water use and water management. For water harvesting, we suggest construction of terraces in slopes, channels, ponds, and dams. Collection from buildings of so the water from buildings, for example, water is coming from rainfalls, dew condensation, and water collection. Other practices that are advisable for a better soil water management is use of water drainage through creation of slopes, channels, tubes, etc., creating a network for removing rainwater surplus, because otherwise it will damage the plants which are in the field. Protect plants from waterlogging, keeps aerobic conditions in order to take nutrients and keep microorganism activity, and in this case we can reduce erosion. Use of water irrigation entered in the practices that is linked to a better water management. For this, creation of ponds, rivers, not polluted, lakes used for irrigation. Can be used different irrigation ways: wide flooding, furrow irrigation, sprinkle irrigation, drip irrigation, trickle irrigation, subsurface irrigation. Here you have the illustration of how the water drainage techniques can impact the root system and the development of the plant. So let's see, for example, the first example, the first case, which is here, the A letter. In this case, we don't use the drainage, and the underground water is very near to the plant, to the root system. In this case, we have a bed developed plant linked to the roots and above ground biomass. The other case, we have drainage, the open or the channels drainage system. In this case, as you see, we have this level of water, underground water. For sure, the underground water is lower near the channel. And you have now illustrated how the plant react, how this form of drainage can impact the plants. So we have the plants less grown here, and the other plant which is developed better. A similar thing we have in the case of another type of drainage system, which is with closed tubes. And here is another example of drainage system. This photo is trying to somehow to summarize all the or most of the agriculture practices which help in better soil fertility management. So we use cover cropping, intercropping to soil erosion control. We use terraces for a better soil erosion control. From the other side, we use in the soil compost amendments, use no-tillage practices, use intercropping, like in this case undersown plants. Another example of intercropping, contour farming, hedges, agroforestry. Diversification of cropland is a very good practice. Use of buffer zones and practices for water retention. And now we almost arrived at the end of this part of the lecture and at the end of all the lecture soil fertility management. During this lecture, I had the chance to speak about different agriculture practices that can be used in organic agriculture in order to keep, to maintain, and improve soil fertility. You learned about different agriculture practices which help for a better management of soil fertility, having multiply effects in different directions to soil fertility. Now, in the next slide, you will find a table which tries to summarize all the most important agriculture practices that can be used in organic agriculture in order to keep soil fertility. You will find by side or on the side of each agriculture practices the direct and indirect effects in the soil fertility and in the soil plant system. Okay, as I said, you can download this table from the repository of this portal and can study in independent way out of this in this video. So let me explain this table. So here we have listed the agriculture practices for the conservation of the soil fertility or conservation of the soil. Here, what does it do? So what does this practice do? And how does it help? For example, speaking about crop rotation, the crop rotation increases nutrient cycling, manages plant pests, weeds, insects, and diseases, reduces shade, reel, and weed erosion, holds soil moisture, adds diversity so soil microbes can thrive. How does it help? Maximizing nutrients, decreases use of pesticides, improves water quality, conserves water, and improves plant production. Speaking about cover crops, they increases soil organic matter, prevents soil erosion, conserves soil moisture, increases nutrient cycling, provides nitrogen for plant use, suppresses weeds, reduces compaction. How does it help? Improves crop production, improves water quality, conserves water, maximizes nutrients, decreases use of pesticides, and improves water efficiency to crops. And so on. Then is coming no-till or no-tillage practices with their benefits and how does it help. And in the next slide we continue. We will see the other agriculture practices which helps in the soil or better soil fertility management. Okay, let me move it here. Okay, so here we have mulch, tillage, mulching, nutrient management, pest management with respective how they do and what or how they help. I suggest you to follow this link and go to YouTube to watch one video that speaks about soil fertility management practices. Concluding this lecture, I wish you good study, easy study, and hope to see you in the next lectures. Till the next time, I wish you a good time.